It's gonna be the null is gonna be equal to 0, and then the alternative is gonna be not equal to 0.
Let's see. Yes. There's actually in the homework, there's a question that's just like this.
Mm-hmm.
Except for, so you're going to see in the homework, the bottom two, where it's equal then and not equal, and then not equal and then equal to.
Yeah.
The top two are exactly like that, but instead of the new symbol, it's B1. So just a quick review, what's this symbol called?
The symbol,
Yes. So this fancy B, what is it called?
beta.
Yes. So we have B and we have beta.
Mm-hmm.
What's the difference between B and beta?
So one is slope. So, well, yeah.
There's
So one
B1
is
and B naught. So B1, B naught, beta 1, beta naught. That's going to be slope and intercept. What's the difference between beta and B?
Beta is, they talked about the residential thing? Visual?
So the difference between beta and B, which is very important, and you will see it in the homework.
Yeah.
Is the same difference between mu and mean, or mu and x.
Oh,
So
unknown. It's unknown, right?
yes, but what's the difference between what's the difference if we're solving for mu versus solving for x? What's mu versus x?
So mu is this is so blah, blah. X is sample mean. Mu is population mean.
Exactly.
Okay, sorry, it's been a while. I was like,
yeah.
oh.
No, and that's why I was kind of surprised to see it pop up. But this is going to be
Yeah.
a good review for the test next week.
Mm-hmm.
So our x is our sample, and then we use our sample to estimate u, which is the population, right? That's exactly what we're doing here. We use b to estimate beta, and beta is going to be the population. So just keep that in mind. An easy way to remember it is you've had it drilled in your head that mu is population, x is sample, right? Like you just got that drilled in your head.
Yeah.
Just remember that beta. So when you're dealing with Roman letters, that sounds weird. These are Greek. Yeah.
Greek.
When you're dealing with the Greek letters, then you're dealing with the population. If you're not dealing with the Greek letters, that's when we're dealing with our sample. So if you see something that asks you what's the difference between B and beta, or if you see a question like this where it's saying like B is equal to 0, B is not equal to 0, you can be like, okay, wait a minute. B is sample. We can solve for our sample. We need to estimate beta because that's the population. So if you see a Greek letter means that it's the population, which is what we need to estimate. So did that make sense, or did that just confuse you?
No, that makes sense.
Okay. Yeah, so just keep that in mind because, yeah, like I was going through the homework and it was B naught is equal to 1, alternate B, like B1 is equal to 0, alternate B1 is not equal to 0. And then B, the null, B is equal to 0, B1 is not equal to 0. And I had to stop and think, I'm like, oh, wait, beta is going to be the population, so that's what we're using in our null hypothesis. Because B is going to be our sample, and we can calculate our sample. We don't have to guess and estimate on it because that's something we can calculate. So just keep in mind, if it's a Greek letter, we're dealing with the population.
Okay. Oof.
Okay, question number 2. Well, I guess question number 4. What is a residual?
Is the difference between the observed value y and the value predicted by the regression line.
That's what I've got. Why is it not the first one? Beta naught and beta 1.
between um well, the simple answer is in in the reading, that's kind of how they put it, is the difference between the observed value. So I guess it's um
So here's a question. What's beta naught and what's beta 1?
so beta 1 is slope and beta, you said not or nah?
Beta naught.
Beta naught is the y-intercept.
Mm-hmm. So what would happen if you took the difference between those two?
You would just get the mean
You would get
between.
nothing useful.
Yeah, you want to get it.
You'd get an intercept minus a slope, and an intercept minus a slope isn't going to be any useful information.
Yeah.
Now, if that said the difference between beta naught and beta, I mean beta naught and B naught, then that could also be considered a good answer, because that is the difference between, well, I guess it would be B naught minus beta naught, because that would be the difference between the observed and the predicted. So keep in mind that's another way to say the difference between the observed and the predicted would be the observed B naught minus the predicted beta naught.
Okay.
So you might see it phrased that way. Just make sure that you understand that that's what the residual is. Is the residual is what we actually measure versus what we predicted we would measure. And since B is what we're measuring, whether it's the intercept or the slope, and beta is what we're predicting, you could plug those into those sentences and make a mathematical equation to say the exact same thing.
Okay, that makes sense.
Okay. A plot of residuals support using linear regression when
So shouldn't it be when you see no pattern?
yes, so they're phrasing this interesting. So let's see.
So it's not when they're all positive. It's definitely not when you see a pattern.
Yeah, because you can definitely, if you could have residuals that are both positive and negative, and if you see a pattern of the residual, definitely not.
And
What does it mean if you see a megaphone?
it means they talked about it in the reading. They said it was if you see the megaphone shape, then the variance is not constant
Yeah,
for all.
that means as you're going further out, the residuals are getting bigger and bigger.
Yeah.
Which means that there's a pattern emerging.
Yeah.
So that leaves only one, and rather than just selecting it, let's talk it through real quick. So the residuals look normally distributed. What does normal distribution look like?
Bell-shaped.
Yeah, so the bell shape, which means that most of them are going to be cluttered together towards a central. And then the further away you get, the less likely it is, you know? So if you were to take that, and let's say rather than doing a bell plot, let's just say that it's a circle. Have you dealt with you haven't taken any physics classes, have you? Okay, so you don't know what an electron cloud is.
Mm-mm.
Okay, that's not a problem. But let's say that we are looking at a point, and it's just a point in the middle here. And if it's normally distributed for x and y, so x can be positive or negative, so that means the dots can go left or right from the central point. Then also for y, the dots can go up and down from the central point. Basically what would happen is you're going to be seeing dots kind of all over the place. And as you get further out from the center point, there's going to be less and less of them, but they're just going to be all over the place. that's what a normal distribution would look like.
Hmm.
Um, if, for example, you're just plotting it on a graph.
Yeah.
And that is actually the definition of random. It gets a little bit more, there's less as you go out further out,
Hmm.
but the thing is, you don't know where it's going to be. You just know that there's going to be more towards the center. And then as you go out, there's going to be a little bit less and less, and they're just randomly distributed. And random, essentially, another way of saying that there's no pattern.
Yeah.
Because isn't that the whole point of normally distributed? The fact is,
That
if
is
something
correct.
is normally distributed, we can basically say, oh, it's normally distributed. That means that this is occurring due to randomness as opposed to a factor.
Yeah.
So, so that's another way you can look at it, is that normal distribution means randomly distributed, and if it's random, then there's no pattern.
Yeah. Okay, that makes sense.
So you could have totally gotten that one just by process of elimination, but I just wanted
Hmm.
to go just a little bit deeper.
Yeah, because like when you think normally distributed, you don't think no pattern, I guess. But once you
Yeah.
explained it, it made sense. Alrighty, so
Self-efficacy. We've used this one like 3 times so far.
yeah.
Question.
So is it the residuals form a linear pattern?
Check real quick. I just barely opened up the files. So for the next
Okay.
8 problems, I just had to double check. Confidence is the explanatory, score is the response. Okay.
Yeah.
I wanted to make sure that I didn't get it backwards like we did
Yeah,
last week.
like we did last time.
So confidence. Confidence is the explanatory. Okay. Residuals. So the residuals are definitely not all negative.
Yeah.
It could fall between -40 and 25, but let me check something real quick. So, okay, I think this is when we have to do a QQ plot. So
Oh,
let's find the Excel sheet that has the QQ. Which sounds weird for me to say because is QQ is basically the Chinese Skype.
oh yeah.
Yeah, it's what my brother used when he would teach English to Chinese kids
That's
just
awesome.
online.
Yeah.
It was like the sweetest gig. They paid him a ton, plus it was under the table, so he didn't have to pay taxes.
Nice.
Yeah, and he could set his own hours and stuff. So yeah, it was on QQ, and they just confused everybody. So he was like, "I teach kids English on Skype." Okay,
So
and that just made people happy. Okay, so it doesn't look like it's categorical data.
it's under the descriptive statistics.
Okay. Okay, so QQ plots. Okay, what we do here then is we actually don't use column A or B, or explanatory or response variable. Instead, what we're going to do is we're going to grab the residuals, so column E.
Just E then?
Yes, just E.
Okay.
So highlight all the information in E, and then copy and paste that over to column A in the quantitative descriptive.
Okay. Alrighty.
I'm having problems with it. Did it work for you?
Nope.
Okay, what are you seeing?
Ooh, it says Excel found a problem with one or more formula references in this worksheet.
Yeah, that's what I'm getting too. And let me try opening up a clean file.
Yeah, I think that's what I'll do too.
Weird. Okay.
Still not getting it.
I think the problem is that's going to be okay. I think the problem is that when we're copy pasting,
Mm-hmm.
the it's
Oh,
copy pasting the equation,
yeah.
and
So
then when it gets over there, it's like there is no equation.
I remember doing this semester. And we had to go to like I don't remember how I we did it before. I think you showed it to me actually, and you had to like
Okay, I got it. Okay, so in F4, go to cell F4 there.
yeah, I'm here.
Oh no,
And-
I was saying, or that didn't work either. Ah, dang, because it's still considering it. Hmm. How did we copy it without recopying the equation also?
yeah, and I remember you telling me how to do it.
Because otherwise we would have to just put it in by hand, and that's just ridiculous.
Yeah. Um,
Is there a way? Hold on a second.
I totally remember that there's a way. I got it.
Oh, what'd you do?
Okay, so I copied just like normal, right? But when I
Hmm.
went to go paste it, I did right click, paste special, and then it came up and I just clicked values.
Oh, perfect. I figured that there had to be an easier way to do that. I'm surprised that
Yeah.
hasn't popped up.
Yeah.
Okay, so paste, not formulas. You just want paste values. Okay. Okay, so and we also have to make sure with the QQ plot, we need to order this from, we can't just copy paste. We have to have the numbers ordered from smallest to largest. Do you remember how to do that?
Mm. Um, mm, Not particularly. Oh, data. It's under data, right?
So you can do it under data and you can also do it under home.
Oh,
So if you highlight the column
uh-huh.
and then to the far right, there's going to be a magnifying glass.
Yeah.
Just next to that magnifying glass, there's an AZ and it
Uh-huh.
says sort and filter. You can
Yeah.
click that and just do sort smallest to largest.
Cool. So I got mine.
Okay. What's your QQ plot looking like?
Um, so it looks like it's between the values are between negative 2.5 and 1.5. Um, there's mostly in the middle.
Oh, wait. Screen share with me real quick because I'm seeing something very different.
Can you see my screen?
Not yet.
No?
Okay, there we go.
Oh, okay.
Okay. Maximize. Okay. Oh, that's the problem, hon.
What did I do?
You're in histograms.
Oh, I did all that in histograms? Oh, sweet mercy.
No problem.
Oh my goodness. I'm just gonna copy and paste this on here. What the heck? I
No
swear I
problem.
clicked on Q fonts. Uh, Alrighty. Copy, paste. Okay, that's what mine looks like.
Okay,
Oh,
that's what I
cool.
got. Okay. And that's a clean, straight QQ plot. So that means our residuals are normally distributed, meaning our residuals are essentially random. There's no pattern to them.
Mm-hmm.
So the residual forms a linear pattern. We can use this.
Sweet.
Yeah, so based on the QQ plot for these residuals, what can you say about the residuals? The
That day,
residuals are fairly normal.
yes.
Okay. Let's ask me. Okay, so you scatter plot. Given the scatter plot, residuals plot, and the QQ plot, which of the five assumptions about linear regression are satisfied? Let's see. So the residuals are normally distributed. The other stuff we're looking at.
Yeah, so this goes to the. So visual check is like if it's like hot dog shaped.
Yeah. And that looks, it could be nicer, but the thing is that looks good.
Yeah, I think it's hot dog shape.
So there's a linear relationship. The residuals are normally distributed. Observations are independent. How do we check for that?
The observations.
Yeah.
And we check them. Those how to check cannot be checked directly. Um, it's knowing the value of one of the y's tells you nothing about any other points. What? That doesn't help. Because
So
this is what it
given
says in the book. I'll show it to you real fast. So this is like the little chart, and sorry, it's not very big.
oh no, you're fine.
So it says observations are independent. It says how to check cannot be checked directly. I mean, the value of one of the y's tells you nothing about any of that. Just doesn't help. It helps with all the other things, but not that one.
No, check directly. Okay, so the fact that it says cannot be checked directly just means that because it's asking specifically, it's not asking are the observations dependent.
Yeah.
It's saying using the scatter plot, the residuals plot, and the QQ plot, can you assume, like which ones can you assume? And since it says we can't check the independence directly, that means that we can't use it using the Excel. So that one would be left blank.
Okay.
Variance, it said basically we're if long as it's not megaphone shape. Was that it for that one?
Let's see. Yeah, so it's the residual plot. No, yeah, it's the megaphone one.
Okay. And then the x values are measured without error. Is that one on? Is that one even on the chart? I can't remember if that one there.
Let's see. The x values are measured without error. Yeah, so it says cannot be checked directly. X's should be measured accurately and precisely.
Okay. So then basically it sounds like the answer is there is a linear relationship between x and y because it's hot dog shaped.
Yeah.
The variance of the error term is constant. There's no megaphone. And
Yeah.
the residuals are normally distributed because the QQ showed a nice straight line.
Okay. Yeah, that makes sense.
Okay. So look back up. Slope then is I got 12.695.
It's not what I got. I got 0.042.
Oh, what's so you're on the linear regression tab, right?
Yeah.
So what do you have as your first number in the explanatory variable?
50.
Okay. You got your columns mixed up like we did last time.
Oh, did I really? I swear I did.
Yeah. So the
Oh.
explanatory variable should start with 4.34, 4.73, and 5.28. And the response should be 50, 83.3, 76.7.
Isn't it aren't we predicting the confidence?
Well, it says,
No, we're
at
not predicting the confidence.
least not yet. It says it says in the instructions, use the confidence as the explanatory, use score as response.
Dang
So it is backwards from what you would think it would be,
it.
but that's what the instructions say.
Okay. So explanatory is the confidence.
Yes.
Okay. I got 12.695.
Okay, perfect. Okay, and then the 95% confidence interval, that's asking specifically for the slope, so not the y-intercept.
So 10.674.
I got for the lower, yeah. And the upper is going to be 14.715. Is that what you got?
Yes.
Okay. Based on the evidence, using a level of significance of alpha is equal to 0.05, what decision would you make regarding the hypothesis test for beta 1?
Okay, so the p-value is 3.3, which is way higher than our alpha. So
Wait, hold on. What's the p-value?
3.3.
3.3 what?
Oh, I should look at that.
Yeah.
uh,
3.3 times 10 to the negative 24th.
so our p-value is definitely lower than an alpha,
Yes,
and
sir.
when the alpha is, or when p-value is low, we reject the null.
Yes.
Let's see, there's reject the null test because it's a typo. The
I didn't
p-value.
catch that.
Yeah. Okay.
Yeah, our p-value is essentially 0.
Yep. All right.
Okay. So for the hypothesis test for beta 1 slope, if you reject the null hypothesis, what does that mean? So taking question 12 and translating it into plain English.
So if we reject the null, there is significant evidence to suggest, or to, let's see, there's significant evidence to conclude that the slope of the regression is, oh wait, is not 0.
So what
Wait.
is our null and what's our
Oh,
alternate
so
hypothesis?
it's gonna be, when we reject the null, we're saying that's not equal to 0. So yeah.
Yeah. So we have sufficient evidence to reject the null, or in other words, we have sufficient evidence that the regression line is not 0.
Yes.
Which is basically saying if if the slope is 0, then that's basically saying that there's no relationship between x and y.
Mm-hmm.
Because if the slope is 0, that means no matter how big or small x gets, y never changes, you know?
Yeah.
So basically this is saying there's sufficient evidence to conclude that the slope of the regression line is not 0, or in other words, there's sufficient evidence that there is a connection between our x and y variables. Does that make sense?
Yeah.
Okay.
Okay.
Then crocodile heads.
Let me make sure I put it in the right column. God.
Okay. The data found for the next 5 problems. Head length was used to predict body length. So for this data, which variable is the dependent variable?
So dependent is head length.
Okay, what's a dependent variable?
I mean, independent is head length.
Yes.
Sorry, I'm dyslexic.
Yeah.
Yes. Yeah,
It
because
says head length is used to predict the body length. The dependent variable is what we predict based on the independent. So we're saying body length is dependent on head length. So body length is going to be the dependent variable.
yes, I did know that. I just
Okay, no problem. We all have dyslexic moments.
gotta love those.
Okay, so we know which one goes in which column, and it's jumping straight to the 95% confidence interval. So let's get that data in there. And make sure it looks like there's less. Yeah, there's definitely less data on the crocodiles than there is on what we just barely did. So make sure to clear out the two columns so you don't get a bunch beneath when you copy paste.
Good idea.
Okay, so head length goes into explanatory. Body length goes into response. Good. We are looking for a 95% confidence interval for B1, beta 1, so the slope. Let me know when you got your answers.
Okay, so the margin of error.
There's a few ways to calculate this. Do you remember how?
Yeah, so it's gonna be blah blah blah. The upper confidence interval minus the lower confidence interval, and then you divide it by 2, right?
Exactly. And then another way to do it would be to minus our predicted slope from the lower of the two, or minus our upper confidence interval, minus our slope from the upper confidence interval. But yeah, I think just subtracting the two, the confidence interval, the high minus the low, divide by 2, I personally think that's the easiest way to remember.
Yeah. Okay, so is it 4.494?
I got 4.442.
You got 0.442?
Yes.
Oh,
What did you get for the slope?
let's see. So for my confidence interval, I got 7.218 and then 8.103.
Okay.
Is that what you
So
got?
that's what I got for the confidence interval. And so what we're doing when we're finding the margin of error is we're finding how far apart they are from each other divided by 2. And so 4 is kind of a big number. What's your equation look like?
So I did, let me do it again. 8.103 minus 7.218 and then divide that by 2. Oh, now I got it. 0.4425.
Okay, I'm assuming, I'm not positive, I'm assuming that you just missed the parentheses the first time.
Yeah, I think that's what happened.
Okay, so that's the margin of error.
So are you putting in
Then
0.443 then?
I got 0.4424, so I'm putting 0.442.
Okay.
Okay, then the lower bound is 7.218. Upper bound is 8.103. And then last question, what is our conclusion?
Okay, so our conclusion is so it's going to be we are 95% confident that the confidence interval will contain the true value of beta 1.
Because when we're talking about confidence, we don't say that there's a 95% chance and there's insufficient evidence. Well, our confidence interval doesn't include 0, so we can confidently say that the slope is not 0.
Yeah.
So definitely the top answer. Okay, so save, submit. Ugh, there's always one. The last few
Dang.
weeks.
What did we get wrong?
Okay, question 6. So go up to question 6.
Oh, let's see.
So I have the residuals form a linear pattern,
So,
which I thought was the correct answer, but we know the residuals are not all negative
so it
because
must
there's some
be.
positive. So it must be the residuals are between negative 40 and 25. So try that one.
I think
Submit.
that is true. I mean, I think it just threw us off because none of the numbers were next, like even close to -40. But technically, they were in between those two numbers.
Yeah.
But
And
it's
it's
just,
just a weird thing to ask, so I didn't bother checking, but it probably is true.
yep, they're between -40 and 25.
Okay, so that gave us 10 out of 10.
Yep.
Okay, perfect. Okay, you have got plenty of time to get your presidency meeting then.
Yay.
Okay. I will email you what I
Yeah,
sent to Sister Cook last week,
perfect.
so you can get on that, and I will see you on Thursday.
Cool. We'll see you then.
Okay, see ya.
Have fun at the ant movie. Bye.